Hope you're enjoying your Devnexus, and I'll do my best to keep the energy up as we move into lunch just after this. Welcome to Cache Me If You Can. Today I'm going to be talking about OpenJDK's Project Valhalla, some of the experimental implementation details, and how you can look forward to using it as a developer when it eventually becomes a Java language feature. Project Valhalla has been in the experimentation phase for many years now, but there has been a lot of changes along the way. You'll get the most out of this talk if you're a Java developer and you have some interest or maybe a bit of knowledge in the JVM, but I'll do my best to explain all of that along our journey here. So my name is Theresa Mammarella. I'm a software engineer at IBM, and I work on the Eclipse OpenJ9 team that is IBM's Java virtual machine. I'm a pretty regular speaker at conferences. I've had experience in the cybersecurity field as well as JVMs and compiler teams as well. And I also help organize my local Toronto Java user group. All right, so Java has been around for a while. If you were in Char's keynote yesterday, it's coming up on 30 years. And a lot has changed in the language and also on the hardware that we run on in that time. So first we'll talk about how that's changed and the problems there that Project Valhalla is trying to solve. Go over value objects and classes. Those are the first Java enhancement proposals that are in draft mode for Project Valhalla. And then what's next and some of the broader changes and benefits that it will have to the JDK. All right, so this probably isn't news to anyone, but over the past few decades, CPU performance has dramatically outpaced that of memory fetches, in a large part due to Moore's law, which is the principle that the speed and the capability of computers can be expected to double every 2 years, which has been roughly true to this point in time. The speed of memory has increased slightly as well, but due to some different reasons, but overall, the gap remains quite large. So one thing that has been a big change over that time period since Java was released was the introduction of caches being widely used in hardware systems. Caches have a trade-off between size and speed, so the smaller the amount of memory and the closer to the CPU you are, the faster that memory fetch is going to be. And when it comes to software, of course, it's important to try to lay out memory in a way that maximizes how we use this to have the most performant software. To give a bit of an idea of how slow it can be when a program is not performing as well as it could be with caching. I have some numbers as well. So I've got latency and bandwidth here for L1 cache down to hard drive. So latency is how long it takes from when you start a request of data until it arrives. It's a bit difficult to measure, so why it's pretty vague throughout this. But as you can see, it slows down quite a bit the closer you get to the hard drive. Bandwidth is the rate at which data arrives, so typically memory is fetched more in batches, such as when you're bringing your laundry basket. In my case, from my basement up to my bedroom, I usually bring all of it at one time to have some more efficiency. So that's typically the easiest to measure and more important for data processing algorithms, which ideally is the types of projects that Project Valhalla is going to help speed up. So one example of how you might see this come up in a program, this is C++ code, not Java, but I think it's easy enough to understand. So what this example is measuring is I have two for loops here, and the idea is to measure the inner for loop where addition on a n-sized arrays occurred, and throughout this graph, the array size gets bigger and bigger. So in this first section here, the memory is bound within, the size of the array is bound within the first level cache, and so the memory, the speed is bound by the CPU. And you'll see that it spikes a bit towards the end of the array size, and that is because that outer loop is becoming less important, so we're getting more increments per second than before. But then there's a dramatic drop just after. And this is what happens when there starts to be cache misses in the L1 cache, and the memory drops dramatically. Drops continue, the bigger and bigger the array gets, because there's more and more cache misses and going into larger and slower phases of memory fetches. So why is this important for Java? In the early days of Java, when the Java virtual machine and language was first designed, the cost of a memory fetch was comparable more or less to a magnitude of addition. And so the design essentially was made to be optimized to this. But nowadays, when it's measured with multi-level memory caches, that memory fetch can be as much as 1,000 arithmetic slots that can happen. So it's a pretty significant change. There have been a lot of optimization work with Java over the past 30 years that makes it so, in reality, it's not so dire, but there's a lot that can still be done. So that's the hardware aspect of it. The next is how do we represent objects in Java, and how can this be modified to take better advantage of that caching? So object representation in the JDK, we use objects are instances of classes that are generally used to represent business logic. The JDK is split into several different parts that have their own interests to have a more theoretically simple model. So we have the Java virtual machine. This has the biggest understanding of what a class is. It understands how classes relate to each other. It keeps track of the stack, has the interpreter, and executes the program, but does not have knowledge of how that memory is allocated. And then we have the garbage collector, which handles memory allocation and cleanup, but has a much more limited knowledge of object relationships. So in practice, the garbage collector is best to keep locality and has pretty good cache efficiency, but because of its limited knowledge of how objects can relate together, there's more that could be done. Objects, when they are linked together, such as through a class with fields, are done so with pointers in the JVM. There are some great benefits to this. One benefit of using pointers is that it's very easy to represent null when it comes to an object. But if you want to access a deeply nested field, which is often done, you need to dereference each object again and again and again. And when it comes to a large Java project, especially one that's doing a lot of heavy data processing, there's going to end up with a lot of object references and objects. They may or may not be positioned near each other in memory, so accessing them can be pretty inefficient. They also take up quite a lot of space, so that darker colored box up there is representative of an object header. An object header keeps track of a lot of information that is useful and makes Java objects so flexible and useful as they are today, but it does increase the footprint, which leads to more garbage collection cycles, which can lead to a slower program. And why do we bother with objects? Of course, in Java, we can get rid of a lot of these headers and a lot of these ideas by using primitives. And that can be done sometimes, but it's, from a user perspective, not the best to represent business logic. Can be hard to read and error-prone as well. And so objects are typically the preferred method to do this, but are not ideal for memory density. So this is a problem that Valhalla is trying to solve in cases where some of that object header data may not necessarily be needed. So for example, if I'm trying to represent a line with 2 points, it's not really necessary for me to know which point is which, for all these points to be separate in memory, because really it's just 4 integers that we're talking about. So with Project Valhalla, it will give the user the ability to express this, that I may not need all of this information, and to be able to indicate to the garbage collector essentially that we can represent this differently in memory. So instead of having 2 different pointers to objects with all these references, instead I can just store 4 integers right next to each other in a very densely packed memory configuration. And so essentially that's what we're trying to do, to be able to take advantage of cache efficiency and be able to process data faster. So one of the key pieces of information that exists in these object headers is the concept of identity. And more than likely you will have experienced this identity when you're using the equals operator, possibly when you should have used the equals object, because equals will compare that identity, whereas equals methods usually compares the fields together. Java objects are all unique, whether or not you want them to be or not. That option is always available to you. Identity is really important for object-oriented programming languages like Java, because it allows the fields to be mutable. They're not static in memory. We can change them and alter them, which is very useful. And also for synchronization. Any object in Java can be used to be synchronized on. In the world of Valhalla, these classes that we're used to, the traditional class that we use every day, is known as an identity class. So a class that has identity, it's unique. But we may not always need to use identity depending on the type of program we're creating. So if I'm talking about a group of people, if I'm representing this in my objects, do they need to be unique? Maybe. It depends what we're talking about. If we're talking about healthcare information, then yeah, probably. If I just want to know how many people are software developers in this room, then I don't know, maybe not so much. When it comes to representing things like money and currency, I oftentimes probably don't need to know the exact identity of that value that I'm talking about. So it's great to have, but not necessary in all cases. So Project Valhalla came about to try to solve this. Some of the goals that Valhalla has and problems it's trying to solve is to augment the Java object model with value objects, which we'll talk about next, are objects without that identity, so that they can be flattened in memory and take advantage even more of cache locality. Combine abstractions of object-oriented programming and the features of Java we've come to appreciate with the performance of a primitive value. So the tagline for Project Valhalla has always been codes like a class, works like an int. And eventually also heal some of the rift between primitives and objects that we'll go into a bit more later, but essentially giving primitives or value objects more ability to use things like generic programming, which can be a bit of a pain point today. There are 5 different feature sets for Project Valhalla in various stages of completeness. The first 2 are, well, I don't want to say mostly there, because they're in draft mode, but there has been a lot of experimentation with them, and there are early access builds that are available to be used, so I'll mostly be talking about those ones today. So the first one is JEP 401. In the Java language, a JEP is a Java enhancement proposal, so this is something that is put forth to community when Java languages are proposed. It's usually iterated on, could come out as a preview feature or 2, and eventually, if it's up to snuff, will be released as a feature of the Java language. And the first one for Project Valhalla is value classes and objects. So the goals for this are, We're adding a program model where objects can be distinguished by their field values, not their identity. Migrate some popular classes to these value objects to increase performance of the JDK for everybody. And maximize the freedom of the JVM to encode values in the way they want, to improve memory footprint by some guidance from users. So the first thing it introduces is the value class. So we have identity classes, which is your traditional typical value class, or typical Java class, and now value classes as well, which is a class without identity. So I talked about previously a few things that identity allows us to do with Java objects. When we're taking it away, there are going to be quite a few restrictions on the class as well. Typically, this type of class would be used to represent a piece of data. So something that you don't want synchronization on, likely, because it's not available in value classes. All instant fields are implicitly final and can't be modifiable. So in order to change the value, you need to create an entirely new value class. And the last one that's going to be important is because there's no identity, the equals operator does not mean the same thing anymore. So instead, it's going to take on the same behavior as what a default equals method would take. So compares all the values of the fields to be equal. Value classes, even though we're not using pointers in quite the same way anymore, are still nullable, and this is important as well, which I'll talk about soon. And the last thing that's important is that all value classes, in order to be flattened, at this point have the restriction that they must be accessed atomically in memory. So in order to represent a value class, there is at least in the current version of the proposal, a new keyword that would come in front of class, such as the modifier that's value, like shown above. All right, one other thing that's being introduced for this is a concept of class preloading. So value classes, typically in the JVM, classes are loaded at the latest possible moment to give the JVM a chance to get up to speed very quickly and start it fast. For value classes, the JVM has a bit of a more aggressive approach to loading these classes. They are speculatively loaded, and it's kind of up to the JVM implementation how this is done. But there is a preload attribute that can be added if the Java compiler thinks it's a good candidate to load ahead. And the reason for doing this is because when it comes to making a decision about whether these classes will be flattened, it's important to have all of the information be loaded so it can be placed correctly in memory. All right, so we talked a bit about before how having a value object can potentially lead you to have flattening in memory. And so when it's lowered from its JVM representation into the garbage collector, we can have a much more dense approach here. So it provides a very flat layout and a dense layout, but flattening is not guaranteed for all value objects, which is why the next step that I'll talk about has come into existence. So because value objects have to be accessed atomically to be flattened, this really restricts the size of value classes that are eligible to be flattened. It depends on the machine, but for some that can be as large as 32 bits, which is basically an integer. So it really limits what can be flattened. So, and actually in at least the OpenJ9 implementation, for a default value class, we're not flattening it at all, because in our experiments at least, it wasn't worth it. And one of the reasons for this is that feature that value classes have, that they are nullable. So as I mentioned a little bit ago, when objects all are connected through pointers, and to represent null previously in this model, we would have a, null pointer, but since the object has been flattened now, it needs to be represented in a new way. And at least for some implementations, the most obvious way to do that is to add an additional bit to say whether or not it's null. But typically, we also want our objects to be aligned. And so that one extra bit can lead to a whole extra 16 or 32 bits depending on the system. So instead of having a value class representing an integer being 32 bits, we would actually have 64 instead. So it can be quite expensive. So the second JEP that's being proposed right now for Project Valhalla is having that value class without that nullability. These are called null-restricted value classes at the moment. In a previous iteration, they were also called primitives, and you might see that as well if you're experimenting with this, but this is at least the latest draft of the spec is null-restricted. So what happens when we don't have any kind of null representation? There could be garbage if you don't declare something, or there could be a default value. And so the decision was to have some kind of default value to mimic, again, how primitives in Java usually work. If you just declare an integer or a double or something, the value is going to be 0 if you don't set it to anything. So that's the same idea here. And so the way that's represented is to opt in to having default values. We have this implicit types of constructor that's in the point2d. So what that means for a value class is if I'm not calling a constructor that is explicitly setting those fields, the JVM is going to set some kind of default value of its choosing. And in order to opt into having a null-restricted value class, so one thing that's different now with this null-restricted version instead of the previous version of primitive, it's that it's granular down to the field level. So that exclamation point there that's in front of a field, that is what's representing or indicating to the JVM that we don't want to have the option of being able to set this field to null. And by getting rid of that, it's now possible to have bigger value classes, and it's more likely that those value class fields can be flattened and take advantage of the memory efficiency. But it's still quite limited, so there's a third option for even bigger flattened classes. We're still limited by having to access that memory atomically. The third option for this JEP is to be able to opt out of that atomic behavior. If you think about it, typical primitives also are not accessed atomically. It's not a rule that long and double, that's a 64 bits, have to do this. You would have to create like an atomic integer or an atomic double. So that could be, for certain programs, something that the risk is they're willing to take. So in a race condition, it is possible that when these types of value classes are created, they may be accidentally intermixed with single fields, but depending on the program and the number of threads, this could be a good option as well. All right, and the way to do that is, at least in the current draft, implementing the loosely consistent value interface. All right, so when it comes to flattening arrays, currently arrays themselves are not flattened and they use pointers, but the components of an array, which are the fields of it, those can be flattened. And so for null-restricted representation, when you're talking about a field, the first one is the valid syntax because we're flattening the component itself, not the array. And the one just below that I have crossed out here that has the exclamation point like after the array is not valid. All right, so that's the current syntax that exists for value classes and a high-level overview of how it's working. So next I want to talk about the impact that value classes may have and things you could think about for using it in the future if it's something that could apply to your project if you're doing a lot of data processing. So How many of you are using Java 17 or above? Nice, okay, awesome. So you're probably somewhat familiar with the feature of records. Records were introduced, I think it was actually like Java 14 or something, but in the latest major release, at least, was 17 that they came about. Records are useful for creating data carrier methods, much like what a value class would typically be for, so these two features work really well together. Record classes, the top example I have is how it's declared, so you just have your class name and the types of fields you want, and then all of the information below is actually generated by the compiler, so you get a lot of free methods that are potentially error-prone and annoying to write that are just there automatically. Records are always final. Every instance field in a record is always final, much like a value class, so these two play really well together. All right, when it comes to migrating to value class, when it eventually becomes time for that, as I've been mentioning, it's likely going to make sense to migrate data carriers, or potentially records are going to be good ones to look at. Currently, the first proposal for Valhalla, JEP 401, some core libraries will also be considered value classes. The exact details of how this is going to work are not, I don't think are available yet, but the idea will be that the classes that are representing primitives like integer, long, float are going to be treated as value classes, as well as optional. So all of these classes are more or less wrappers, and they can have a few different levels of indirection that can lead to some inefficiencies. So having them as value classes is going to just smooth out some of that messiness and also increase performance overall. So starting in Java 8, there's this concept in the JDK documentation of value-based classes as well. So the JavaLang optional that was on that list, that one came out in Java 8, and so that's one example of a class that is considered to be a value-based class. So if you're using this in the specification, it's not currently enforced, but it does say that when you're using these value-based classes, it does need to be treated like a value class, such as it shouldn't be something that you are using for synchronization, and also treat objects with equal values as substitutable, not basing them on their identity. All right, so migrating some of these value-based classes to Project Valhalla is one thing that is going to hopefully increase the performance of the JDK overall, whether or not you're using a lot of data processing or not. There's also some new compiler optimizations, like just-in-time compiler optimizations, that will be more possible and easier to do than they were before. So one of those is escape analysis. And this is a compiler optimization that goes and determines whether or not a field is contained within a method. If it is, if nobody else uses it, if no other threads use it, you can potentially just allocate that memory onto the stack and not have to go through the heap, and that can be faster. But because Java objects use pointers, it's a little possible, but it's really hard. And having value types will provide more opportunities to be able to do this. So one example is up here. So if you're just looking at this program, you can probably tell that, so I've declared the foo and bar objects here. I pass foo into bar. It doesn't go anywhere else in the program, so that could be an option for escape analysis, for just storing those variables on the stack. But a compiler, it's challenging to narrow that down with all of the pointers that Java has. All right, so that's a bit about Project Valhalla, at least the parts that are like available in experimentation releases to use right now. At the moment, there's a lot of work that's been done, and the call to the Java community at the moment is to get involved with projects that may be of benefit to this, to provide feedback on the mailing lists that are there, if it's something you use, whether you liked it, whether it helped. I put a link to OpenJDK's early access builds here. I would highly encourage you, if you do go and use these, to read the release notes very carefully, because this is an experimental project and it has been changing a lot, especially in the last year. So that's something you'll definitely want to read. In OpenJ9, we have our own support for value types as well. We don't have EA builds, but it's pretty easy to build if you're an OpenJ9 user as well, and eventually that will be part of our summer runtimes too. So there's what's next for Project Valhalla. There's 5 big language sets that are eventually scheduled to come out. The first 2 we talked about today with the null restricted classes and also value objects. The next ones will be around making generics have compatibility with value types, and there's some exciting features to come. So that's all I have for you today. If you haven't had a chance to stop by the IBM booth, we have some lightning talks happening over lunchtime and socks and swag to give away. Otherwise, thank you so much for coming and enjoy your lunch.